Die Stummschaltung ist aktiviert.
Session, it's about parametrization and Tecplot Chorus 2016. The agenda for today, I will tell you something about the basic idea. Then we are going to visualize, speaking about what it means visualizing many results, what is the problem. Afterwards, I will speak about this solution. I will speak about huge data sets and Chorus. And after this, and these are just a few slides, I will show you the first example, Aerodynamics, which is Chorus basics. It's a pretty simple example, but it explains what Tecplot offers to you. And in the second example, I will speak about the automotive. In this case, it's an automotive example from the automotive industries, and it's about a customized Chorus. So this is a real case, yeah. And as a third example, very short, the application of Chorus in the marine, so shipbuilding industry. Then we have the chance for question and answers. So the basic idea, Tecplot 360 is a great post-processor, but there are some situations where you, for example, have to manage hundreds or thousands of results. The question is, what are you going to do then? Yeah. Of course, you can do a lot with macros, and you will learn in my Monday webinar about macro programming if you're interested in. But if these are really hundreds or thousands pictures, for example, it can be pretty complicated. So, and what are you doing? How do you compare lots of different cases? Say that you have 20 cases from 5,000 cases you would like to compare. Yeah, for example, different views, different slices, or whatever. So how do you do that? And how do you focus on specific cases and how to find them? For example, filtering. Yeah, how would you do that? And this is really a task. And how can you access immediately these data sets for further inspection? That's another question. Will you create something like a folder structure or to find exactly what you want? So if we are speaking about visualizing many results, then we have to do, for example, with data spread over many files, directories, subdirectories, and we have to do with finding, organizing, and visualizing these data, and this is very time-consuming. So we have that problem that the data is spreaded. We have the problem that the visualization is time-consuming, and we have the next problem, which is that this can lead to mistakes in the result interpretation. Yeah, for example, you could theoretically confuse data sets because their names are pretty similar, and the solution for this is this is a product which is Tecplot Chorus, which is a major breakthrough in parametric and optimization studies, and this gives you an overview of all your results at a glance and organizes your data. So in other words, this is a management tool. Data is available for you then at any time right at your fingertip, and it will save for you a tremendous amount of time. And it reduces mistakes and makes results easy to communicate because it is clear that there is a one-to-one order of your data sets so that you cannot confuse any of these data sets. The next point is, of course, I will show you this in a couple of minutes. The next point is that what is about if you want to visualize a huge data sets. For this, you have Tecplot 360 2016, yeah, which is on the market since I think 4 weeks or something, and this is really the best Tecplot you ever will have seen for huge data sets. But if you have many of them and you have the same problem, as before. Then you need to organize them in a useful way, and this is done with Tecplot Chorus 2016 because this uses Tecplot 360EX. And the point here is that Tecplot EX 360 2016 uses, for example, subzone load on demand technology, which is absolutely brand new on the market. And meanwhile, we support TechIO MPI, so parallelized output via MPI. So you can really have huge data sets, and they will be organized with Tecplot Chorus. And that's what I'm speaking today about. So let's start with some practice and not with PowerPoint slides. And I will show you now how Chorus is organized and how it works. Go now to my Tecplot Chorus icon. Double click here, start Tecplot Chorus. And my first case is a very simple one. Just 1 second, I would like to show you the data structure, which is behind that you have a better understanding what I'm talking about. So we have here a case where we have 32 different simulations, and this names here of the directory structure means, for example, Mach number, Mach 004, alpha and beta are angles, so alpha 0 degrees, beta is 0 degrees. You see that parameters are changing, and so this is the order. This is the structure which I will use then in Tecplot Chorus. And the easy idea around Chorus is the following. Let me open this simple CSV table here. This table contains now the parameters which you have seen before. Forget about the right side. These are dependent parameters. But here, this is an important part. We have a link to your data, yeah, and it can be several links to a data set. And we have the parameters here, the independent parameters. Mach, alpha, beta, you see here 0400, as you have seen in the data structure. This is all what you need for Tecplot Chorus. Then you load that table, and as a result, you will get the table in Tecplot Chorus. So here you see an overview over the different graphical modes you can work in with Tecplot Chorus. But I will start with the table view. So this is Tecplot Chorus 2016, and what you can see here is the following. On the left side, you see the parameters. You see here statistics, for example, you see here we have many results with a low alpha value and a few results with higher alpha values. So this is a basic statistics. You can filter your results so that you can focus on specific results. So, for example, if we apply an alpha filter, then you see that the table will shrink. Yeah. Additionally, you will see as this red bar here, which what is so to say, which area is filtered currently, and this little arrow here. I hope you can see that. It's small on my screen, so I have no clue how small it is on your screen. But here's a little arrow which shows you in which range you currently are with this value. So with 10, we are more or less in the middle. That's how the table view works, and the basic idea of having this linked with your data is the following. You simply click on one of these lines, so you are interested in this parameter configuration, and let's say in this one. Now I have marked 2 of my cases. Below you see 8 and 18 are marked, and we click on with the right mouse button and we say view data. And here we could theoretically now apply style sheets or macros to your files. I click on OK. Tecplot 360 will start, and in this case we see an empty plot, or not empty, but it's not colored in some way. And now you would begin to color this. For example, we switch on the contour. We would like to see the contour for the Z velocity. We shift the legend here, switch off the bounding box. Perhaps you are interested in the contour lines. So I switch here to flooded lines. Okay, let's say that this is the view you would like to work with. Then I do nothing else but to save the style template, and I call it, for example, AA1. And we can synchronize the styles, and now we directly can compare both data sets. Well, that's nice to have. So if I close now Tecplot, I can work with arbitrary cases, and I easily can select now as a style template, my style template. I click on OK, and after a few seconds you will see your 3 cases with your style sheet of your choice, and you can compare them. So that's so easy. Yeah. I close Tecplot once again, and let me show you something different. I prepared some pictures for this case, so that I can show you something without generating them. In the background, I will mark any of my cases, and in the background I will create now images. So click on Create Images. The width of the image may be 1000 points, and I call it, why not? It was Z velocity, something like that. So I can call it ZVel for Z velocity. I click on OK, and now Tecplot Chorus will work with Tecplot in the background and will create all these images for me, so that I don't need to always have a deep look into the data and start with Tecplot. Good. Okay, that's the table view. Another point is you can sort here your values, so you can sort your cases after the values. If you're interested in high drag or low drag, then you simply click here, and then you can mark the cases with the highest drag, for example. That's another thing you can do with this table. Well, let's come. This is just a short introduction to Chorus. So let's come to the next view. This is the matrix view. In this case, I had a DoE simulation, design of experiments. So you see here some gaps, and you see here an order. I ordered these pictures, which I already created. Alpha and Mach, for example, are the independent parameters after the images are ordered. Okay. If you are interested in a specific case, in this one or this one, once again, of course, you can click on View Data, and then it automatically opens, and you can select the style sheet so that you exactly see those both cases in, let's say, reality in your Tecplot. Well, that's the matrix view, and you can easily switch here, for example, between the different pictures and compare all of them. In this case, in the matrix view, what you see here is CP plots from my from this example, which is pretty interesting because you can combine macros and style sheets to get such a plot. Let me show you how it works. Let's say that you are interested in a specific case. Let's say this case here, and you would like to see the CP plot. Then you simply go to a macro CP cuts, and then I additionally select a selection, for example, cut number 2. Now Tecplot will start the macro and automatically create my CP plot from a cut from a cutted slice, and all of this is done automatically. And of course, I can create pictures from this too and give them back. Well, that's the basic functionality of the matrix view. Here is where you select the order, and in this case it's paged by beta, because for several plots for this here you see that we have more than one plot depending from the beta, and you are not restricted to the number of parameters of the parameter space. Well, next view is this one here. This is a 3D view where you see all the simulations which has been calculated, and this bubbles here, of course, every bubble is one of the simulations. They are colored. If you check the left, they are colored after the lift parameter, and the axes are Mach and alpha. And what you additionally see here is a second order spline, which is the response curve, and this is used for some statistics if you want to understand better what happens, for example, for points which are not calculated. If you would like to see this in as a line plot, then go here. Here we have our line plot, and this in this case we have here the different alpha values for which those lines are cutted, and these lines here, these are the interpolated lines, yeah, and you can see here the estimation which alpha and which Mach value, which drag value you would get if you are around here. The next is that we have 2D scatters. So this 2D scatter here is, if you check on the left, it's colored by the variable drag. So we have Mach, alpha, and drag. And here it's nice that we can color by filter violations. So currently everything is in this pink tone. At least it looks on my screen a little bit pink, and every point here is green, so every filter is satisfied. But if I now go here, and you see, if I move the slider, then I violate at least one independent filter, and this means that those three simulations here would be filtered now. And you can so work with a combination of filtering and have a better understanding what happens. For example, if you go to drag, and now you see a light blue, and so this here violates a dependent filter. Okay, that's about the basic functionality in Tecplot Chorus. So you see what can you do with Chorus. You manage your data sets, you manage your results. We can meanwhile load our new images, we deposit them, and after a short time you will have a new picture. So going here, we have now ZVal, and this is the Z velocity pictures which we created before, and now you have a complete overview over all these pictures. Well, and this is the basic functionality in Tecplot Chorus. It's managing your results, you have quick access to your results, you have statistical tools, and this helps to understand trends in your data sets. So it's a really mighty tool. What I would like to show you now in the second example is pretty advanced, let's say. So I'm on this slide here now, customized Chorus, the image viewer. This is a customized Chorus, and currently I did not compile this add-on for Tecplot 2016. This is the only reason why I'm using Tecplot Chorus DE 2013 for this specific customization. And what I'm doing is to load a big case. So we have here, in this case, 100 different simulation runs, and we have, if we check the image base, for example, I click here, click on View Images, then I will see that we have thousands of images. So these are different images, for example, for the different parts of the objects, for the mesh, for specific parts of the surface, how it's meshed. Then the physical values, for example, pressure, CP values, and so on, vorticity, and all of this are simulation results, and we get different pictures for them. So as an example, I can select a group that you have at least an overview what it's about. You see here on the right side, you have all the different groups of pictures. So you see in the end, we have thousands of results, and which we want to understand. How does it work? I can select now a group. So I will select the group sample, and now you see here a sample, and this is something like a car, and it is in NACAR simulation, meaning this is standard thing when you would like to tune your simulation, and if you would like to check if the complete process which is done automatically, so all the post-processing results have been post-processed automatically. And in this case, Tecplot Chorus is nothing else but an image viewer, yeah. But we want to have more. We have, for example, hundreds of slices through different positions in our car, and we would like to understand better what happens if you going slide by slide through the object. One example, yeah. And so we speak about image groups, and additionally we would like to have unlimited resolution of the pictures, because in Chorus here you can resize, but you get to a limit. And what if I don't want to be restricted to this limit? I think this will come in a future Chorus version, perhaps in the next one. Nevertheless, we need a solution for this, and so you have to see that you can easily extend the possibilities of Tecplot Chorus, and this is called actions. And what I'm doing now is I will mark, let's say, 3 different cases. This case here, and let's say this case here. Yeah, you can of course you filter before and you decide, but I just guess here that this may be interesting cases, and I click on Launch Tecplot. So this is not standard Chorus. This is an so-called action. I start this action now. Okay, I started the action, and now we have here the 3 cases which I have chosen, and for these 3 cases we would like to see now single images. So I add single images, clicking here. Oops. One back. I go to post, and these are the post-processing results, and here I search for interesting pictures. Let me show you this one, and for example this one, and here we have isosurfaces if you would like to see them, or here surface stream traces. Okay, that's it. I selected now my picture types, and I refresh the view, and now I have those pictures available in Tecplot directly in the common Tecplot. And what I can do now is something pretty nice. I can zoom in to any of those parts, so I can directly compare different sections of my plots, yeah, in arbitrary resolution. And of course you would see that there are differences, yeah, like here and here. But these differences may be pretty small. So what you can do in this extension is I click, for example, on this picture here as a reference picture. And now just 1 second. Here we are. There's my image viewer, and now you click. I selected this picture as a reference picture, and now I click on image diff, and now automatically there's a difference plot created, so that I see from this reference where are the parts of this picture where I see the biggest differences. That's one of the options you have here, or for example the same for this plot. So if I refresh and I select this picture as a reference, I click on image diff, and I will get the difference, and I will see where are the biggest difference in my plots. Okay, we refresh once again, and now what if you would like to have this pictures bigger, and if you would like to let's say flip through the different pictures. We have a mode for this. We simply select all of these 3 cases, 1, 2, 3. These are the cases, and I go to the flip mode, and in this flip mode we now are able to, for sure we are able to zoom in and so on, but we are flipping now, and this means that we are, you see here, the case is changing. We are flipping from case to case in this example, and of course feel free to zoom in to the resolution you would like to see. The next feature is that we can do an image diff of all the pictures if we would like to, but the most impressive then is that we have an image group viewer, and this means if, for example, I remove here 2 of this case of this picture types, 2 are removed. Now let me add an image group and explain you what this means. Scrolling down, here we are, my pictures. Post-processing. And here I have, for example, different clips through my data. And let me, for example, select clip Y, CP plots. I select this one, and now I go to refresh. Now I see my image group. And now let me go through that group, and you see you will have now here changing positions. And all of those ones can be easily compared. Yeah, that's how to. This is to demonstrate you how you can work with Chorus in an yeah, I would say advanced mode. You can customize Chorus as you like to. It's the so-called actions. We created here one specific action, which we call the image viewer, and yeah. Feel free to ask me if you want to have more information. Please never hesitate to contact us. if you have any questions about Tecplot Chorus, about actions and so on. And as a last little example, I would like to show you something from the shipbuilding industry. And here we open and we see that we have here wave patterns, and these are here two-dimensional wave patterns, and here we see the geometry. And if we click through this simulation, this ship flow simulation, then we see, if I go down, yeah, you see here the transmission width and the transom depth is changing, and you simply go down and can compare any of your results. So this is just another standard example, like the UAV example in the very beginning, which demonstrates how you work with Tecplot Chorus. Well, let me check my PowerPoint slides, and I would say that's it. If you would like to have further information, or let's say support for Tecplot, then try a free version of Tecplot Chorus. And by the way, if you download Tecplot Chorus, then you have automatically an installation of Tecplot 360, because this is usually the post-processor of your choice. One remark about academic customers: if you are academic customer and you purchase a license of Tecplot, then Chorus is automatically included. Yeah, so just that information. Okay, if you have support questions, email to support@tecplot.de, but I would recommend to call us. This is mostly much easier and costs not so much time as writing an email. You can get support with online meetings, and please check our webinars. Very new is that we have a free Tecplot certification. You please check our website www.genias-graphics.de/certification, and there you have the chance, the opportunity to get your free Tecplot certification. Okay, that's it. Contact me for more information. Thank you very much. I'm Jens Wackerl at genias-graphics.de. And now I will stop the recording and I will be open for your questions.